All right, this is our video for Thursday, April 23rd, Pre-AP Algebra 2. Our objective today is to look at applications of linear equations. On Monday, we reviewed function notation, domain and range. Tuesday, we reviewed slope and graphing. Wednesday, we reviewed writing equations. Today, we're going to look at applications of our linear equations. All of the homework for the week is due by midnight tonight. And then tomorrow we're going to have an ACT style quiz over what we've talked about this week. All right, you're going to need your books open to page 81. And we're going to be looking at number 2. Now, when we did applications from chapter 2 in class, we looked at scatter plots and we used the graphing calculators and we had all those steps. And those are very important, particularly if you're going to take AP statistics. You will have to do that. And then we also do it in pre-cal. We don't do it in calculus, but it is an important skill that you need to know how to do scatter plots and to apply different models as we have practiced throughout the year. But you can also do applications just by hand. And that's more of what would be on the ACT, and that's what we're going to look at today. So if you look on page 81 at number 2, it says a pump removes 1,000 gallons of water from a pool at a constant rate of 50 gallons per minute. So there's a swimming pool, and it already has 1,000 gallons of water in it. That's its current amount of water. They are removing the water from the pool, so they're draining the pool, and they're removing it at 50 gallons per minute. And they're removing it, so it would be, if we were graphing, it would be going down. So this is our rate of change, which is also our slope. And so it is changing. It's going down 50 gallons per minute, and it started at 1,000 gallons. So this would be our initial amount. Okay. So A says write an equation to find the amount of water Y in the pool after T minutes. So Y is the water in the pool. And instead of X, they're wanting us to use T, which is the time in minutes. So a little bit different, but we can handle that. So instead of Y and X, we're going to use Y and T. And so they want us to write the equation. So if this is the initial amount, this is how much water was in the swimming pool at the beginning before anything happened. So that would be when the time was 0. So they're giving us the initial time. So they're giving us at t equals 0, there were 1,000 gallons, and that is our y-intercept. So they're giving us a point there, and they're giving us the slope, or the rate of change, is negative 50 gallons per minute. So we have a point and we have the slope. And yesterday we talked about how if you have a point and slope, you can use the point slope formula. And so I'm going to plug in the y sub 1 is 1,000. Our slope is negative 50. And I'm going to use t because they want us to use t instead of x. And the initial time was 0. And so when I clean this up and I distribute, I have negative 50t, and then this would just be 0. And then I move the 1,000 over. And so I have this equation, y equals negative 50t plus 1,000. And this represents the water in the pool over time, which is what they ask us to do. And then this equation could be used to figure out, okay, so how much water is in the pool after let's see, this was minutes. So let's say after 60 minutes. So we would take our equation and we would put in 60 minutes and we would multiply and we would get if I use 60 minutes, I'm going to get 3,000 gallons have been emptied out of the pool that only had 1,000 in it, and it would be negative 2,000. So that wouldn't be a reasonable question to ask. So always, think about your answer and see if it makes sense, because there are only 1,000 gallons to start with. So a better question would be, instead of 60 minutes, 6 minutes. And so if I did 6 minutes, then I would have that 300 gallons had drained out in 6 minutes, and so there would be 700 gallons of water left in the swimming pool. So you can take information and turn it into linear equations, and then you can use the linear equations to answer questions. And we did that with our scatter plots. You would have to, the calculator generated the equation for you, and then you could use the equation or the graph to answer questions. So you're going to have a problem today, and it's going to use your reading skills, and there's some other information in there, but within that problem, you're also going to have to write a linear equation. Now, one more thing I want to talk about up here, we could have, if you know the slope and the y-intercept, you can use the slope-intercept form of the equation, and we could have just plugged directly in, but I wanted to make the connection back to what we had talked about yesterday. All right, so for today's work, you're going to have, it's just one worksheet, and it has a table of some information, and then it asks you to answer several questions based on that information. And remember, we will have a quiz tomorrow. So if you have questions, be sure and Zoom at 9:30 tomorrow, and our quiz will open up at 10 o'clock.